Spotted wing Drosophila update 2017. It was not a great year. Just a little recap. I think everyone in the room is probably familiar with this pest, but I'll go through just at a basic identification, what we're looking for, some of the damage, some of the symptoms that you should be looking for. Just a very kind of highlight of the results we had. I'm going to not focus so much on the nit-grit of the research, but more or less how the populations did and where we saw the greatest damage, and then spend some time on some of the management tools that are being used, and certainly research, so throughout the states, so Oregon, northeastern states, Ontario, BC, and sort of give you a sense of what's going on out there. So spotted wing Drosophila, genus species Drosophila suzukii. This is a very close relative to the small vinegar fly, or the small fly that you find hanging around your compost bin. This originated from Asia. It's thought to have hit mainland North America in 2008 in California, and then it's rapidly moved up the west coast, hopped over to Florida. The hypothesis is that it came into North America through imported fruit. By 2011, I should say by 2010, it was pretty much in all of the northeastern states. So Michigan, Maine, all along that northeastern seaboard. By 2011, we found it in Nova Scotia in what we now know to be very small numbers. So I think by the end of the season that year, we had maybe 700-800 flies in total. By 2012, we saw a 40-fold increase where we were up in the tens of thousands. That year, New Brunswick picked them up, PEI, and then in 2013, we actually found very small populations in Newfoundland. And those populations have continued. Every year we pick them up. There is still some discussion, although it's sort of calming down, on whether they're established here. For 3 years, we monitored year-round and could not find these flies more or less after December. If we had a really weird week where the temperatures were warm, a couple years ago, if I don't remember, Christmas Day was like 17 degrees, all of a sudden we would see a dozen flies in our trap again. But for the most part, they fall off the radar. We don't see a thing until July, August, and voila, they're back. So if I were to graph that population curve each and every year that we've been sampling, so since 2011, it's the same bubble every single year, suggesting to me that they're here to stay. So I swear it could go very wrong. So this is the male here. The common name spotted wing is basically after the male. It's got two very distinctive spots on the wings. If you are looking in your traps, or you dump your traps into a kind of a white bowl, white container, those spots look about the size of a pepper grain. So you would see two very small spots. There are some other characteristics that are unique to this species, but as far as I'm concerned, they can only be seen, or I can only see them under a microscope. So for practical considerations, you would definitely want to be focusing on these two spots. The females do not have those characteristics, and this is the summer morph. So the winter stages of spotted wing are actually a little bit different. They're darker in color. They typically are smaller. But the female doesn't have those spots. But what she has is a very distinctive ovipositor. An ovipositor is basically just the structure that she lays her eggs with. And here's a blow up here. So what you see is, on the one edge, she has a really quite an impressive serrated edge, kind of like a steak knife. And this allows her to land on a ripe fruit. So when I was talking about these being close relatives of the normal little vinegar fly that you hang around your compost, they have a much closer relationship with fruit that is breaking down, rotting. So they have a very close relationship with the yeast that are produced when fruit is post-ripe. Spotted wing Drosophila prefers the fruit. We think they get overwhelmed when the fruit is starting to break down. So they have a preference for fruit when it's ripe. And this ovipositor allows her to actually land on the berry, and then with that edge kind of make a slice, and then she can insert the ovipositor into the fruit and lay the egg. Once in there, then the egg will hatch. And as in most insects, each life stage is really temperature dependent. So this is assuming, 8 to 14 days per generation, but 8 days to go from egg to adult, you'd be looking at probably 25 degrees, 24 degrees Celsius. So it can range anywhere depending on the temperature. So basically, you have the egg stage, and we see that here quite a bit. It's a size of it's exceptionally small, maybe 1 to 2 millimeters. It has 2 little filaments that kind of stick out. But what you see when you're looking at it's much easier to see on something that has a smooth skin like a blueberry as opposed to a strawberry or a raspberry. So what you see is the egg is inside, but these are for basically, for lack of better words, breathing tubes. And you'll see those 2 little filaments kind of sitting on the surface of the fruit. And I have pictures of that. The eggs will hatch. You'll get 3 stages of maggots or larvae. Each stage just is basically eating the fruit from the inside out. The fruit often doesn't drop off the vine, so it just kind of starts to, you'll see it's sort of starting to soften and break down, but it can often stay on the plant. Then they'll pupate. This is just a great shot of the pupa kind of poking out of the fruit, but sometimes they'll drop. Here you can see it on the calyx of the blueberry. And this is pretty much the life stage in all small fruit. We've seen them in strawberries, raspberries, blackberries, wild blueberries, high bush blueberries, not so much in wine grape, and a lot of wild hosts. So for damage, what you're looking, these are very, very small maggots, and if you think of, for folks in the room who grow high bush blueberry, these maggots would be probably 4 or 5 times smaller than a blueberry maggot. So they're quite small. What you would be looking for is sort of softening of fruit. So in blackberries and raspberries, the individual, someone help me with the name of the druplet, will start to actually cave in. So they'll just break that down from the inside out. Blueberries, it just happens to the whole blueberry. Here is a maggot, but it's very hard to see against the texture of the strawberry. So what you're basically looking for is a softening. Once they go into far stages, then you get a lot of maggots. This is actually strawberry, and they can break the fruit right down in a matter of really hours. This year I brought in blueberry, or folks gave me blueberries, and they sat on my desk in a Ziploc baggie, and in 24 hours I had pupa. Again, this is in blackberry. So this is what I'm talking about. This is the surface of a blueberry, and you can see the filaments here of the egg. And usually what happens in the hole where the egg has been laid, you'll get secondary problems. So these holes can leak, inviting, bacteria and fungi. So we've been monitoring since 2011, and it's really the royal we. There's a whole bunch of folks who have been participating in this, definitely Perennia, Erica, Kat Benedict. It's a very large group, Pete Burgess up north. I'm going to speak to the work that we've done. We've been doing this since 2011. We conduct weekly sampling, and we've been using these 16-ounce red, so beer cups. We use black contrast bands, which is just a piece of black electrical tape. We leave about 3/4 of an inch space on one side of the cup just for easy pouring every week, but the rest of the band is hole punched with about 1/4 inch hole for the flies to go in. We hook these up. We have little sort of gaskets here, and these are meter stakes, so we like them about 1 meter off the ground. We try to put these in places. These are very small flies that are susceptible to desiccation, and they're not very good flyers. So try to put your traps in sort of cool, shady areas where the sort of foliage or the leaves aren't blocking the holes. We're also monitoring, we're still working on our degree day model, so we're monitoring temperature at all the sites that we're at. We use an apple cider vinegar, and we cut it. It's laced with some 95% ethanol because we know from research that that's actually a little more of an attractant than just plain apple cider vinegar. We also use little tubes where we've punched the hole out of the top, and we have little mesh screens, and we do a yeast mixture. And I'm happy to send you, if you want very specific recipes, not a problem. We add a little kind of yeast, sugar, water. There are folks out of Michigan actually prefer, rather than apple cider vinegar, they just use a yeast, sugar, water mixture in their cup. But it is my recommendation to producers that you stick with apple cider vinegar. It is a conservative attractant, so it won't get you as many spotted wing as I do. But in terms of processing, unless you have somebody that's doing your processing for you, it's exceptionally hard to filter those tiny little flies out of basically fermented yeast mixture at the end of a week. So with apple cider vinegar, it's clear. When you dump your traps on a weekly basis, as I've said before, just go to Dollarama and buy a big white bowl or something with sort of a kind of a flat, large surface area at the bottom. Dump your trap in and look for those pepper grains, those black spots for the males. One point, do not, when you dump your traps on a weekly basis, do not pour the apple cider vinegar. Don't just dump it out in the field with you. We bring empty jugs with us, and we take the waste and pour it and remove it from the field. So don't leave it there to potentially attract more flies. So results for 2017. We found our first detection this year the week of June 30th, which was approximately a month earlier than we've ever found it since first looking. Michigan was a month early. Ontario was very early. BC was early. This was just a very early year. My thinking is, we know that the flies go into the winter in very high numbers, and the sort of theory is that they get knocked down very heavily, and that's not unexpected. There are a lot of insect species that can actually, because there's so many of them, that can actually go in the winter, and overwintering mortality can be 80, 85, 90% of the existing population. But when you're in the millions, that still leaves a little resident population. If they can survive until spring, they kind of have the foothold. This year we saw cherry, I think here in the valley was certainly, there was one point in June where we were probably 2 to 3 weeks ahead in terms of the actual plant development. And so I'm thinking that when I look at the data, when I look at our actual sort of the data of the fly counts, it's my thinking that there were probably that sort of temperature boost that pushed the cherries along probably also gave the resident population a little heads up early in the season. And I say that because this is normally when we find the first detection, we find a fly, maybe two, and then in subsequent weeks we'll have lots of zeros, and then all of a sudden around August we start to pick them up again. And by sustained catches, what I'm referring to is then from that point on, every week we find them. This year, the week of June 30th, we found a couple, and then then every week after that, we found more. And it just slowly kind of climbed until it started doubling and tripling populations. Again, the data that I'm presenting is specific to our trapping in the valley or western Nova Scotia. We continue to find higher counts outside of the crop. The ratio used to be 3 to 1, so 3 times as many spotted wing on the edge versus in the crop, but we see some fields where we have 5 to 1, but for the most part, they stay kind of outside of the crop. We know that we see the captures that we find in the crop, we seem to see a relationship with the harvest. So when you get very close to harvest and the fruit, there's a lot of ripe fruit, and especially at harvest where you likely have some fruit that's been damaged through the harvesting the sort of process, we see kind of a flush in numbers. That has been consistent since we've started monitoring. And then sort of post-harvest, once things have settled down a bit, after about 3 weeks post-harvest, we see the numbers drop almost completely, and then they jump back up in the woods. And this year, as in other years, we found lots of fruit infestations. I'd say this year was probably comparable to what we saw in 2012, so considerable fruit infestation. So just to show you this year, again, first detection was the week of June 30th. In July, our average spotted wing per trap, the mitt ranged somewhere between 0.7 flies to 1.78, so just under 2. By August, that jumped to 2.5 to, in some cases, 23. And these higher numbers, you can go to the bank. These are near the end of the month. So you're seeing this probably at early August, and by the end of the month, we were on average finding 23 flies in a trap. By September, early September, we were seeing almost 24, and by the end of the month, we were 180 on average. The issue for me this year was that these numbers are typically, for the most part, these are about a month early. In past years, we would have seen this number in November. So this is problematic given how many crops are being harvested at this time. So this is just sort of phenology that I've been tracking because we're working on this degree day model. These values come from the Oregon model, so we're trying to tighten that up for Atlantic Canada. And I've been kind of monitoring these. These are basically heat units calculated on base 10, so more specific to the insect. And we have 2017. So what you see is we'll have nothing, nothing, nothing in terms of fly numbers, and then we start to see some growth, but often we do not detect them until they're quite high. So by the time that we're actually picking them up in our traps, there's quite a few out there. What I wanted to show this graph specifically for is this line here, this pinky, I don't know what color that is, this line here versus the blue. The blue is from 2012 and this is 2017. These are the two main years that we saw a considerable amount of damage in terms of fruit infestations. And in both those years, we ended up going into another generation. So this line here is the peak emergence for the 4th generation adults. So I find that interesting. We would certainly have to tease that out more. So just to end on some management, between talking to colleagues and then going through the literature in preparation, I want to spend some time sort of talking about how to go forward. So I think everyone is in agreement that monitoring is key. There are a number of commercial traps you can buy out there. Great Lakes IPM, I think Halifax Seed might have some. They typically are quite a bit bigger than the Solo Cup. So my cautionary tale is they catch a lot more of everything. So it will add to the amount of time it takes you to process those. But lots of folks are still sticking with deli cups or beer cups. So you need to trap from fruit set through harvest, I would say, are your critical periods. And you can expect your first counts to be in the border. So I would say if your time is pressed, which I'm sure it is for most of you, and you can put traps out, you can put a limited number of traps, my advice would be put them on the borders first. We've only seen an exception to this. There were 2 years where in raspberries, when we found them in the border, we found them in the crop at the same time. So that may be sort of something to take into consideration, that if you're doing commercial strawberry or raspberry, you may want to put a trap in the crop and then about 50 meters away on the edge. But for the most part, if your time is limited, put your traps on the border. Again, trap from fruit set through harvest. There is no calculated economic threshold to date. So there are lots of guesses out there, and those have been wild and varied. They sort of shift as we learn more. So yeah, so be careful what you read, I guess. And then if you find, if you're starting to find high numbers, especially in your crop, if you're starting to see spotted wing in your traps within the crop, that is, I think, time to test your fruit. And the next slide will go in how to do that. And then, of course, if you're finding larvae in the fruit or you're finding flies in the traps within the crop, it may be a time to consider managing. So a couple things specific to dealing with the canopy. The thing that the flies kind of enjoy on the edge is sort of the dampness, the shade. So our data, when we go off outside of cropping systems into sort of wooded areas, non-cultivated crops, away from farms, we can find a lot of spotted wing. as the years have progressed, we're seeing more and more populations sort of outside of agriculture, but they're always near a water source. They're always where it's sort of damp and shady and protected. So, so try to keep your sort of field, check your drip lines for leaks. If you've got sort of, wet areas within the cropping field, I would say try to address that, because that will be a nice place for them. And of course, there's work that just came out of Michigan that was very interesting on sort of pruning. They looked at pruning and different ways to sort of manage the canopies to sort of open it up so that the fly couldn't enjoy the sort of shade. Of course, it works really well if you're working on sour or sweet cherry. Not so much, not at all if you're working in wild blueberry. And I would argue, it's very difficult in strawberry and other crops. But it is something I wanted to put there as a way to say that so when you're sort of removing leaves or removing canes, those types of things, that you're just sensitive to the fact that the more open that canopy is, the less amenable it is to spotted wing. So for management testing fruit, we typically, when we start to see them in our traps, we bring the fruit in and we incubate them, and we look for adults to emerge. And of course, that's because we have the luxury of having incubation chambers and all the resources to do that. For yourselves, the saturated solution works well. You can use a saturated sugar solution or a saturated salt solution. I prefer salt because sugar just makes a mess. And if I'm going in the field, the easiest thing to do is buy a box of Ziploc baggies. Actually, the ones that have the two tracks, because they will leak. And put your cup of fruit in there. And if you make up your jug before you go out in the field of your saturated salt solution, you can just sort of add it to your fruit, and then just gently. You don't want to macerate the whole thing into a smoothie, but you just want to kind of break up, say, half the berries, and then set it aside on the front of your cab and head off and do other things. Leave it for about 15 minutes. I typically have better success if I come back to it after about 30. But you'll see. So you can see these are the maggots here. They're exceptionally small. Same in blueberry. And I will warn you that when these maggots emerge, it's all maggots. This is not a technique that is specific to spotted wing Drosophila. So if you have blueberry maggot, also if you're trapping, if blueberry maggot happen to be in your field, they can also emerge. But there are ways to tell the difference. So if you want to save your sample and bring them in, I'd be happy to look at them. But we know there are effective trapping methods for blueberry maggots. So I'm sure you're all on top of it if they're in your field. But this is by and large the sort of quickest method. And if maggots emerge, then my recommendation would be consult with Perennia or your guide and start to make plans for managing the field. So wild hosts, I've had a lot of questions about this. Our data over the years has suggested, and this is sort of now and accepted, that spotted wing use the edges tremendously. In fact, it's likely that that's where they live and that they just kind of move in and out from the woods into the crop when the fruit is there. There is work that's suggesting that honeysuckle, we know that they really enjoy the wild bramble, so wild raspberry, wild blackberry, pin cherry. We've reared them out of a lot of things. Some research has suggested that honeysuckle, by and large, is your best predictor. That if you've got honeysuckle and it's fruiting, collect that fruit, because if spotted wing are around, they're likely there. So crops adjacent to these wild hosts are probably at the greatest risk of early damage. We know, this is sort of my lecture. The labels on pesticides don't permit you to extend that management option outside of the crop. And I would also argue that it's probably a very expensive proposition, because we don't really know where the flies are when they're there. So to go in there and spray very expensive product is probably not effective. So the advice that folks are sort of sharing with growers is keep the field edges tidy, free of brambles. Now, I roll my eyes every time I say that, but I think one thing that we might be able to do is sort of either hedge or prune off. If you can prune down some of the big patches of honeysuckle or wild bramble down below the fruiting zone, that will probably go a long way. It would certainly push the flies deeper away from the field. Timing of harvest, shorten the picking intervals wherever possible. Certainly in the northeastern states, they harvest raspberries and blackberries every second day. And there's some talk about if you have, when the raspberries are, as they're ripening, you'll get those sort of, the smaller harvest initially before you get the majority. And it's probably worth your while, even though it's time consuming, to take those off. So pick your crop early, clean, and often. There is talk about freezing of the berries, so that works very well if your berries are going to processing. So freezing does work. We know it kills the eggs and the larvae. Yes, they're in the fruit, but they're now dead. If you're talking fresh market berries, we know that refrigeration helps. So there was a paper that came out of, I want to say, North Carolina, that tested and felt that if you could hold it at, I think it was 1.67 degrees Celsius for 3 days, then you got 100% kill of eggs. As you go through the maggots, the different stages, that success rate goes down, but it's still quite high. By the time you get to the oldest maggot, you're still getting 75, 76% mortality kill by freezing, by keeping your berries cold through the sort of processing line. So I've had a lot of questions about what to do with the culls. There was a lot of work done on could you bury them and deal with them that way. Oregon researchers found that so the minimum depth has to be 30 centimeters, which is about a foot. Oregon found that if you just simply dug a hole and buried them, if the ground is sort of cool and damp and whatever, I can't think of another word, but that probably didn't give you the kill that you wanted. But work just came out of New Jersey, and they demonstrated in their research trial that if you buried the culls in a hole of sand, so if you have a hole and they're buried under basically a foot of sand, that they got 100% kill. So there's been really good work on solarizing fruit that's come out of Oregon. So if you have small amounts of culls, then you can use clear or black plastic bags, just kind of close off the bags and lay them out in the sun, and that in time that will actually kill them. If you've got a much more, your cull pile is much higher, you can also, I think it's a 2 millimeter thick plastic that you can drape over it, tuck it, you can kind of bury the edges around the cull pile, and again, same principle. And they've actually found really good success with that. Composting is not effective. The flies, the various stages can do quite well in that system. The key is, and you can see the bucket here that I borrowed from Wendy McFadden Smith, is not to leave your culls sitting out there. Really, at the end of the day, you need to deal with the culls. So whether that's putting them in a hole and burying them with sand, or putting them under a big sheet of plastic, but don't leave them sitting there day after day. And that happy news has come to an end. There were a lot of folks that went into collecting all of this data and doing this work. Thank you.